Let's quickly talk about redox reactions. Okay, redox reactions. The word redox is coined from reduction and oxidation. So the RED here stands for reduction, while the OX stands for oxidation. So what happens during redox reactions? When in reduction reactions, okay, there is gain of electrons, while in oxidation reactions there is loss of electrons. Okay, so you can always remember it using this oil rig. Okay, oil rig. This is R, oil rig. So O, oxidation, is loss. That's what the OIL stands for. Oxidation is loss of electron, while reduction is gain of electrons. And there are rules that govern this redox reaction. So we're going to quickly look at those rules. Okay, the first rule states that all three uncombined elements have an oxidation number of 0, and this does not exclude diatomic elements. Okay, it includes diatomic elements, elements that exist in this diatomic state. Some of them, let's say O2, O2 exists in diatomic state. Okay, even these two, okay, even in diatomic states too, they also have an oxidation number of 0. Okay, and another element, let's see, S8, sulfur 8. Okay, when these elements, even though they are diatomic, when they exist as free elements, they have oxidation number of 0. Then the second rule, the second rule states that hydrogen in all its compounds except hydrides has oxidation number of +1. So anytime we say hydrogen rather, we always compare to hydrogen 1 plus, okay, +1. In most cases, hydrogen will have the oxidation number of +1, while the rule number 3 states that oxygen in all its compounds except peroxides has oxidation number of -2. So most cases, whenever we say oxygen, we always compare oxidation number of -2 to negative to oxygen. All right, so armed with this information, let's see if we can solve some few examples. So let's quickly go back to this first slide. All right, good. Okay, so the question now is, what is the oxidation number of chlorine in, let's say, hydrogen chloride, HCl? Like, if you remember the second rule, we said oxygen carries positive, right? +1. So if oxygen carries +1, and we need this compound to have a net charge of 0, if the net charge of this compound has to be 0, therefore chlorine will carry -1. So that by the time we're plussing the charges, we can say 1 positive plus 1 negative will get charge of 0. Okay, let's look at another example. Let's say something like this: potassium, let's coin this, okay, permanganate. Okay, good. What's this potassium, right? So what is the oxidation number of each of these elements in this compound? All right, so let's start with oxygen. In our third rule, we say we convert 2 minus to oxygen, -2 to oxygen. So, and then we have 4 oxygen, right, atoms here have 4 oxygen in this compound. So what will happen is -2 times 4 will give us, so this oxygen, the whole of this oxygen will have -8, right? Then we also know that potassium can exist as positive because potassium chloride exists. So if potassium chloride exists and chlorine has negatives, and potassium can have positive, so we can assume that our potassium here can have positive. So we're left with, what is the oxidation number of manganese in this? Okay, so we can easily add it up. If we're going to get a net sum of 0, so we can say +1 plus -8, right? So we're going to get -7. So that -7, this remaining -7, will be the oxidation number of manganese in this. Okay, but then this, let's look at another tricky one. Simple but tricky. So I'm going to erase this. I'm going to erase this. It's very simple but tricky. Let's say, what is the oxidation number of nitrogen in this compound? Let's say NO3, and then has negative charge. Okay, in this compound here, we're saying that everything, all the elements combined here within this compound, the whole thing has a negative charge of -1. So if we're going to look for that of the oxidation number of nitrogen in this compound, we must also remember that the net charge of this compound is -1. So by the time we balance our charges, we must have -1 left. So that's the trick. Okay, so oxygen, we said oxygen contains 2 minus, so 2 negative, -2 times 3. So for oxygen, we'll have -2 times 3, we'll have -6. Okay, and then we have 1. We must account for this one. So if we're going to account for this negative, that must remain. Therefore, nitrogen in this compound, we have +5. Okay, therefore nitrogen will be +5, so that by the time we are adding, if we add -6 plus +5, we're going to get -1 left, and that will become the net charge of this. It's that simple. So what we're going to do next, we're going to look at oxidation. We're going to look at redox reactions in acidic reactions. We're going to see oxidation and reduction in acidic reactions. Then we're also going to look at oxidation reduction in basic reactions. Okay, that way we can easily understand, have deeper understanding of redox reactions.